Hi guys, welcome back for another video. We are starting 1.5 today, and this is our last section in chapter 1. And I actually split it up over 2 days, so I don't know what day you're watching this, but we did it in class on the day before Thanksgiving break. So I thought I'd split it up, not overload anybody. So we'll finish the other half next time, which will be the day after Thanksgiving break. So I will let you look at the starter and go through those problems. We'll just start on number 1. I just had everybody in class take a minute and review what a square root is with their neighbors, and they just kind of wrote some examples down for each other. So I'll just kind of review here on the video. Most of you probably remember that's the square root symbol. And, a lot of you, I'm sure, remember that when we take the square root of something, it's actually just the opposite of squaring something. So you really think of a number that when you square it equals 25, which is 5. So yeah, squaring something and taking the square root of something, just total opposites or inverses of each other. So in class, most people kind of came up with a lot of the classic examples, square root of 64 equals 8, things like that. Somebody asked a great question in class, what if you had something like this? Something like the square root of negative 25. Well, you can't really square anything and make it equal to be negative 25. Somebody chimed in and said, well, what about negative 5? Well, if you square negative 5 times negative 5 is positive 25. It doesn't equal negative 25. So the answer to this is actually, I believe the way our book puts it, is not a real number. Not a real number. Later on in the trimester, we'll actually learn about these crazy things called imaginary numbers that will help us deal with this situation when we have a negative inside of a square root. But for now, just put not a real number. What else did people bring up in class? Somebody brought up something like, well, what if it doesn't come out nice and even, like the square root of 10? There's no nice whole number that when you square it, it equals 10. There is a decimal that you can get pretty close to squaring and equal 10, and that's kind of what the square root button is for on your calculator. This is like 3.16, and it goes on, but not everything comes out even. Later on in the trimester, we'll also talk about ways to get the exact answer for that and not have to rely on decimal approximations. So today's lesson, did you know that there are more roots besides square roots? There are a lot more. So just take a minute, let's talk about third roots, fourth roots, fifth roots, and beyond. Just a little vocab. When we talk about all these different kinds of roots, they're also known as radicals, which actually, if you look back at the title of the lesson, radicals is part of the title. So that means square roots, third roots, fourth roots. Any kind of root is called a radical. Here's a formula, if you'll write it down on your notes, that will kind of expand your math world beyond just square roots. So if some number x to the n power equals y, then if you go the opposite way, the nth root of y will end up going backwards and equaling x. That might not make a lot of sense just with all the letters here, so let's put in some numbers. So if I have, and we'll start kind of simple, but if I have something like 2 to the third power, well, 2 times 2 equals 8. So if we go backwards, so this will be the third or the cube root of 8, and that's just the opposite, so it'll end up equaling 2. So just like the square root is opposite of squaring something, the third root is the inverse of doing something to the third power. And you can think of crazier numbers than that. We won't get too crazy for the examples, but if I had something like 5 to the 4th power, I believe that's 625. So if we go the opposite way, the 4th root of 625 equals 5. So taking something to the 4th power and doing the 4th root, those are just opposites of each other. Now all of a sudden I'm not feeling super confident in that. Is 5 to the 4th power really 625? 5 to the 4th power. Yep, I just checked it on my calculator. In class, somebody said, well, does this work for really big numbers? It does. So now that I've got my calculator in my hand again, so they had me do kind of like a large example. So 23 to the 5th power on my calculator, that tells me that it is this large number. And so just going the opposite way, the 5th root of, what is that, 6,436,343? Well, it's just 23. So that expands your math world a little bit. There aren't just these square roots, there are other roots, 4th roots, 5th roots, and they're just the opposite of the 4th power, 5th power. So number 3, let's do some official examples here, and we'll see some negatives sprinkled in throughout the examples to see kind of how we deal with that. Example 1, the 5th root of 32. You might know that right off the top of your head, but you might not. So if you didn't, you just start exploring on your calculator and say, okay, what is the number that when I take it to the 5th power equals 32? So you'd start investigating different numbers to the 5th power on your calculator. It ends up just being 2. So the 5th root of 32 just equals 2. Example 2, the negative 4th root of 2,401. This one, unless you're some kind of Rain Man type person that can do math in their head, you probably don't know that one right off the top of your head. So you're trying to think of some number to the 4th power that equals 2,401. So you do a little investigating, try different numbers to the 4th power. You can actually pause the video and try it out if you want. I think, if I remember right, it ends up being 7. So 7 to the 4th power equals 2,401. So our answer is 7. You might say, wait a second, what about this negative in the front? That negative doesn't do a whole lot. It just hangs out there. So our official answer is negative 7. It's like whatever this 4th root is times a negative 1. That's all the negative's doing there. Back to square roots for a second. The square root of 36. If you want to, you're always welcome to write a little 2 in there, just so you remember it's the square root. Most of you are saying, well, that's 6. There are actually 2 answers to this one. Is there another number that when you square it equals positive 36? And in class, most people were quick to say, well, it could also be negative 6. So with square roots and other roots, actually whenever the number out there is an even number, technically there are two answers, and you can write them both out, or you can take a little shortcut and write a little plus or minus and then a 6. So primarily for now, we're just going to talk about the principal square root, which is the positive one. But just keep in the back of your head that for some of these, there are actually two answers. It could be plus or minus the thing. Okay, so now these last examples, notice they all have negatives inside of the root, inside of the radical. So let's see how that works out. First one, third root of negative 27. So I have to think to myself, is there some number that when I take it to the third power, it equals negative 27? If you're exploring on your calculator and you're doing different things to the third power, I'd highly suggest, remember those parentheses are important and we talked about it in our last video, but get those parentheses around the number so your calculator will give you the correct answer. So after a minute of exploring, kids in the class were like, oh, it's negative 3 to the third power equals negative 27. So does that really come out negative? Negative 3 to the third power is negative 3 times negative 3 times negative 3. If you multiply these two together, you get a positive 9 times that negative 3. And hey, it really is negative 27. So that was just fine. The answer ends up being negative 3. No problems there. Now, what about this one? The fourth root of negative 81. Fourth root of negative 81. So we need to find some number to the fourth power that ends up equaling negative 81. And kids tried for a minute. A couple of them actually said negative 3 to the fourth power might work. But that doesn't. When you have something multiplied by itself 4 times, it'll actually end up being positive. Negative 3 times negative 3 is positive 9. That also equals positive 9. So you're going to get positive 81. So it was a good try, but it didn't quite work out. So after a while, everybody was saying, well, I don't think there's a number that to the fourth power will equal a negative number. It won't equal negative 81. And you are totally right. So not a real number. Not a real number. And let's keep going. We'll kind of get a pattern to all this in just a second. Example 5, the fifth root of negative 32. So is there something to the fifth power that will end up equaling negative 32? Go ahead and pause the video, try it out. We've already done similar things, but when you're ready, unpause it. And it seemed like most of the kids in class came up pretty easily with negative 2. So negative 2 to the fifth power equals negative 32. And it really does work out. If you times a number by itself 5 times, it will end up coming out negative. So that worked out just fine. Taking it back a little more simple now, the square root of negative 16. Pretty much instantaneously, people said, not a real number. So kind of the pattern, and you've probably already caught on, but if this index number, that's the official name of it, is the index number, is odd, you can do a root that's negative. But if the index number is even, you can't do a root that's negative. And it worked out that way in all of our examples. If you look back through the whole thing, that's the way it worked out. Now, in class, to finish out, our homework assignment was actually just kind of a quick group activity. I didn't want anybody to really have any homework over the break. So if you're watching this at home, no assignment today, just have a great Thanksgiving break. We will come back the day after Thanksgiving break and we will finish up this section and then we'll have like a real assignment with that. So hope you have a great break. Stay safe, stay healthy. See you after.